Yes, good morning, friends. Today we are doing our microwave practical, which is based on a rectangular waveguide test bench. So, here you are observing a practical setup for the microwave test bench with the use of rectangular waveguide. Our today's experiment is to observe the reflex klystron characteristics. So with the help of this setup, we are observing the reflex klystron characteristics. So basically reflex klystron characteristics is nothing but a graph which is plotted between reflector voltage and the output voltage. So on x-axis there is a reflector voltage, on y-axis there is output voltage. So if we change the reflector voltage, what the changes are done or what the changes we observed in the output, that we want to discuss here. So let us have a look over the total connections of this particular practical. So you are here observing a klystron power supply. Now this klystron power supply itself here connected to the klystron mount. So here it is a klystron mount on which the klystron is placed. This is cooling fan to cool the klystron. Now with the help of flanges, the klystron mount itself gets connected to the isolator. So isolator connected to klystron mount with the help of flanges and this nut and bolt type of arrangement. Now the variable attenuator itself gets connected to the isolator. Now the function of isolator is to block the reverse energy. So whatever the standing waves created, if these standing waves are harmful to the source, then this particular block, which is called as isolator, it blocks the reverse energy going towards the klystron. So during forward journey there is no isolation provided, but during reverse journey the isolation for the microwave energy itself gets provided. Here you are observing the variable attenuator. Then variable attenuator once again gets connected to the frequency meter. So this is your frequency meter. Now there is a connection between frequency meter and the slotted line. So here also you are observing a detector mount, so through which we can observe the waveforms or connect this output to the CRO. Now here you are observing a detector mount which is connected to the CRO, and this is nothing but the CRO on which we are observing the waveforms. Right. So this is our basic experimental setup as per the block diagram. So here you are observing a block diagram. So first of all, klystron power supply gets connected to the klystron mount and klystron. Then it is connected to the isolator, then variable attenuator, frequency meter, slotted line, then detector mount and CRO. So tunable probe is here to connect your slotted line to the CRO, right? So same is the case, klystron power supply connected to the klystron, then isolator, then variable attenuator, then frequency meter, then slotted line, then detector mount, and finally it is connected to the CRO, right? Now here you are observing a graph which shows us the characteristics of a klystron. So on x-axis there is a reflector voltage and on y-axis there is output voltage. So we are just changing the reflector voltage, and what changes we observed in the output voltage, that we are going to note down here, right? Now basic experimental setup procedure is here observing here. So connect all the components and the equipment as shown in experimental setup. So we have connected it. Then the next step is keep the variable attenuator to the no attenuation position. Now here you are observing the variable attenuator. Okay, so extreme outside position, it is nothing but no attenuation position, and if we move this variable attenuator to the downward direction, attenuation gets increased, right? But for getting proper output, we have to keep this variable attenuator position to zero attenuation or no attenuation position. So it is nothing but the extreme outside scale where we are observing is zero attenuation. Then the next step is that select the different switches position on the klystron supply. So here you are observing a klystron supply. So this is your meter select switch. So voltage, current, repeller. Then modulation types CW, AM, FM, external. Then here you are observing a beam voltage knob. Here it is repeller voltage knob. Then for AM, if we want to change the frequency, then there is here is the knob provided. If we want to change the amplitude of AM, then knob is provided here. So same is the case for FM. If we want to change the frequency knob is here. If we want to change the amplitude, then amplitude knob is there. So at initial conditions, I am just placing this knob to the center position, right? Okay. Now as per the procedure, keep the modulation knob to the AM. So already it is placed here at the AM. If I change it, then it becomes FM, then external. So I am placing this knob to the AM, right? Then the next step is that keep the beam voltage knob fully anti-clockwise direction. So here you are observing a beam voltage knob. So this is a clockwise direction, this is anti-clockwise direction. So beam voltage knob must be kept fully anti-clockwise direction. So like this way. Now keep the repeller voltage knob. Here you are observing a repeller voltage knob fully clockwise direction. So it is anti-clockwise. Now if I am moving to like a clockwise direction, then this is your clockwise direction. So fully clockwise direction. Then the meter switch to the beam voltage position. So meter select knob. So here you are observing a meter select. So it is on voltage position. Now rotate the frequency meter at one side. So I am rotating this frequency meter to the one side. Okay. Then the next step is that switch on the cooling fan, klystron power supply and CRO. So I have make it on the klystron power supply. So beam voltage knob at minimum position gives beam voltage of 200 volt. So you are observing here 200 volt beam voltage. So at the initial condition, the beam voltage should be your 200 volt, right? Now to observe the waveforms on the CRO and to propagate the microwave through the test bench, you have to do some steps. So first of all, increase the beam voltage up to 300 volt. So here I am increasing the beam voltage. So this is your beam voltage now. So I am increasing the beam voltage up to 300 volt. So 299, right? So approximately equal to 300 volt. So 298, 299 it is applicable. So 300 volt you are observing here. So 300 volt. Now just by increasing the beam voltage up to 300 volt, we have to wait for 1 to 2 minutes to respond the klystron tube. So we will wait for 1 minute here and take a time to respond the klystron tube, right? So here you are observing a cooling fan. So while doing the operations, the klystron tube generates some kind of heat. So because of this excessive heat, there is a possibility of damage of klystron tube. So we are always using a cooling fan for cooling purpose of a klystron tube, right? Now if we observe here, so 2 points are available for taking the output, one at the detector mount and another at the slotted line. So the CRO probes get connected here, right? So this is the initial position of a CRO you are observing here. Once we get the output of the microwave test bench, we are observing a square wave on that particular CRO. So after getting output, the straight line gets converted into the square wave, right? So this is the basic experimental setup. Okay, so now after waiting for a 1 or 2 minutes, then I will reduce the klystron beam voltage to 265. So this is beam voltage knob. I am reducing the beam voltage to 265. Okay, so 267, 266 is also okay. Now next procedure is to observe the beam current. So here you are observing, so I have selected the knob on current here. So 17 milliampere current we have observed here. So the extreme current should be 30 milliampere. So the beam current should not be more than 30 milliampere. So here you are observing that it is 17 milliampere, so it is below 30 milliampere, right? Now change the meter switch to the repeller position. So here you are observing I have just changed the knob to the repeller voltage. Now change the meter switch to the repeller voltage position and repeller voltage knob to the maximum point gives 235 volt, but here you are observing 275. Okay, now decrease the repeller voltage to get a proper square wave on CRO. So I am just reducing the repeller voltage until I get a square wave on CRO. Okay, so here you are observing a square wave. Now I will just increase the amplitude here so as to get maximum amplitude CRO wave, right? So here is the maximum position you are observing the CRO square wave. So just by increasing and doing some adjustment in the CRO. Yes, so dear students, here you are observing a square wave which is needed, right? Now this is the basic experimental setup for any kind of waveguide, microwave waveguide operation. Now the next step is that once the square wave is observed, adjust the amplitude knob, we have already adjusted, and the tunable probe of a slotted section for getting maximum amplitude. So AM knob we have already done to the maximum position. Also we have changed the slotted position so as to get the maximum AM wave. So if we observe that, if we move the slotted line, then the square wave gets reduced. So it is some minima point we are observing, so it is minimum value. Then if the once again if I increase it, then the maximum value I am observing. So if we change the position of the slotted line, different types of minima and maxima points we are observing. So maximum amplitude itself is nothing but a maxima position, minimum amplitude it is nothing but your minima position, right? Now here you are observing the observation table here. So in observation table, the first block it is serial number, then repeller voltage, and then the output voltage. So basically whatever the repeller voltage we have observed here, it is 192 volt. So for 192 volt we will measure the output voltage. So on CRO, the number of divisions I have to calculate. So here you are observing 1, 2. So 2 multiplied by, here is the multiplication factor, right? So it is 0.2. So 2 into 0.2, it is nothing but the calculations if we do, right? So for repeller voltage minus 192, output voltage it is 2 multiplied by 0.2, so it becomes 0.4 volt, right? In the same way, it is nothing but the first reading I have taken for the repeller voltage. So suppose, reflector voltage. So here is the reflector voltage. For reflector voltage 192, I am getting a reading of 0.4 volt, right? Now we have to take 2 or more readings. So 1, 2, 3, 4 readings I have to take. So just by changing the repeller voltage, and we are observing the different outputs. So I will take one reading. Okay, so if my repeller voltage it is 151, now I will measure the output voltage. So it becomes 1 into 0.2, that is 0.2 volt. So for minus 151 volt, so output voltage is 1 into 0.2, that is 0.2 volt, right? In the similar way, we can take the different readings and plot this particular graph. So on x-axis there is a reflector voltage, so that is 192, 151, right? And on y-axis there is the output voltage. So such a kind of graph it should be plotted, right? And which gives us the characteristics of your reflex klystron or klystron tube. Clear? So this is our first experiment we discussed. Hope all of you understood. So in our next experiment, we will conduct another practical of which is on microwave test bed. So just observe